Hello, everyone. Welcome to today's presentation. My name is Jason Johnson. I'm a Senior Applications Engineer with IMAGINiT Technologies, and today we're going to be talking about a holistic approach to digital transformation. So, wanted to start out by framing the conversation with a quote here about simplicity is the outcome of technical subtlety. It's the goal, not the starting point. And because a digital transformation is a complex journey, we want to make sure that we kind of keep this in the back of our heads. Nothing is quick and easy when it comes to this level of complexity. And we're going to try to walk you through some of the approaches that we here at IMAGINiT Technologies like to take with our customers, and hopefully gain a little bit out of that. So first off, why digital transformation? What is the big hubbub about it? Well, first of all, we started back in the day, back in when I first started, we were still on drafting boards, sitting in a dark room, with pencil in hand, and soon after that, they brought in some computers, and our drafting desks turned into the desks for the computer. And that really kind of started the whole digital transformation in manufacturing, design, a lot of in architecture. And we've been on that journey for a good 20 years or so. And I think now we're starting to see the pace accelerate. And what we're seeing now is this, obviously the transformation into the digital age, where we're trying to take advantage of more technology out there to streamline processes. And in fact, the three kind of principles we take to digital transformation is, adopting disruptive technologies, realizing more value out of your IP, and trying to replace some of those manual processes. So when we approach a digital transformation project, these are the things that we kind of try to keep in mind when we're working with the customers and trying to help them achieve their goals, and putting in these kind of principles to help support those goals. And so, there is quite a bit of legitimacy around the digital transformation. Right now, we've got a majority of the Big 10 consulting agencies out there, anything from Accenture to McKinsey, IBM, they're all creating these digital transformation maturity models. And these guys specifically for manufacturing. And what that does is that helps companies realize where they are in that digital journey. Are you still coming off the drafting board, or are you leading some kind of best in show, best in class kind of transformation journey where you are starting to realize some of the benefits that we've been promised all these years? So some of the main effects that we see from digital transformation is closer relationships with customers, greater value chain integration. These are the things that we're not finding. This is coming from Harvard Business Review, in their surveys to manufacturers out there, trying to get an idea of what it is they need or want out of their journeys. And those are obviously the benefits and goals for a lot of companies out there that are, talking in, those yearly annual strategy meetings, upper executives talking about things just like this: closer relationships with customers, value chain integration, and what have you. Digital transformation helps get us to those lofty goals. And another Harvard Business Review survey, we did see, some of the barriers to digital transformation. You can see here, probably the biggest one is the inability to experiment quickly. Typically, what we have is, everybody's so busy, they don't have time to, learn about these new technologies, take the opportunity to test them out in their own environments. And then we have legacy systems where all of this IP is locked up in a system that was created 15 years ago, perhaps by someone coding in the corner of the office, And all of that data is locked in there because that person is no longer with the company, nobody knows how it works. And then an ability to get across silos. So one group not being able to talk to another. So these shouldn't come as a surprise. This is kind of the stuff that we've seen, you know, as struggles and challenges to the industry over the last 10, 15 years as these technologies have come on, and the adoption processes are becoming slow, but we do see that there's a lot of customers, once they get through that, they start realizing some of those benefits from the main effects chart on the left there. So that's basically what we kind of the approach and some of the high level information about digital transformation, at least from the IMAGINiT perspective. So next, we'll get into navigating the digital complexity, the actual digital transformation journey. So what we see with digital transformation are all of these disruptive technologies, new applications, new workflows, and bigger ways to tackle some of these problems. And where a lot of companies are seeing is they might be overwhelmed. Like, there's so much out there. We don't know what's right for us. There's just too much to take on. We don't have the internal resources. There's, all those barriers that we were talking about. And it doesn't help that there is just this plethora of technologies that have exploded over the last 5 years. So what we're trying to work with companies on is take your strategic goals, and let's see if we can tie them into specific points of these disruptive technologies and kind of eliminate all the others. There's a nice quote out there that says, simplicity is removing the obvious, adding the strategic. And that's what we want to do here, right? We want to remove the things that wouldn't be right for a customer and focus on the things that are right. So in someone's case, we might be implementing things that are, related to the digital twin, some systems engineering with reality capture, and some industry 4.0 with industrial Internet of Things. That same digital transformation journey may not be right for another customer. They may be looking at adopting 3D printing technologies, using generative design, and having more simulation and analysis on that stuff, and then all the way through, taking it into some advanced manufacturing where we're, doing 5-axis machining and what have you. So, obviously every customer's digital transformation journey is going to be different. And again, it's about removing the obvious, adding the strategic. But one of the issues that we've seen with even trying to take on 2 or more of these is we get into the complexity of, the n-squared problem, as every new technology, or originally every new function you added, you're squaring the number of interfaces that are possible. So as you start adding on all these new technologies, you have all these intricate interconnected technologies that need to be worked on to make them function together. So as if implementing one wasn't bad, try adding 3 or 4 on, and you can see that it can start getting pretty messy. And one example here, we have a 15 by 15 grid, and out of that 15 by 15 grid, we have only 38 missing, and that leaves about 187 different interfaces between each of these things. And this is one of the reasons why we've seen some companies fail, is they try to take too much, bite off a little bit more than they can chew, right? So this comes down to getting roadmaps in place, setting future goals, and trying to figure out what can we do now and what's going to add more value. So again, what we try to do, instead of having that large 15 by 15 grid, let's take it down, let's shrink it down, and here what we're doing on this next slide is kind of what that process would look like. So here, if we take an example of one of the companies, first off, they want to implement the digital thread. Great. Well, they also want to add in some simulation, virtual reality, and then eventually digital twin. Well, we start taking a look at that, and there's a lot of interfaces that go between the different technologies. So when we were looking at just implementing the digital thread, you have all these different processes that you need to either adopt or change or, kind of fit into. And then there's the technology piece that has to come along with it. So we can see that just implementing a single disruptive technology can be a little overwhelming, even for larger companies. But then we start adding in the different technologies like simulation, and then going into the virtual reality realm where we have other, even more processes, more technology to work with. Finally here with the digital twin, we've got all these different, again, more processes, more technology. And these little blue dots are how two different technologies will communicate with each other, what leads into one and what does one feed back to another. So here you can see that, on a 4x4 grid, we're not just implementing 4 technologies, but we're implementing, 12 different interfaces between those combinations. So again, scale is important when we're talking about digital technology or digital transformation, because the more we add, the more the monster grows. And where we again come in is try to remove that obvious stuff, help with the strategic, map out these feedback loops between the different technologies, along with just implementing the technologies on a standalone basis. So now we'll kind of see what does that digital transformation look like, and kind of got a little philosophy here, what we call design, connect, and extend. So first off, if we think about the design space, we are taking our CAD utilities and making prints and drawings and all this other stuff. And as we've seen over time, even the CAD stuff is getting more sophisticated, to whereas we start seeing that we can put more data, more relevance into these models. So we can do things like material specifications. We can do utilize purpose-built tools that help us design faster. We have parts lists where we can, obviously, put all the purchasing information into the parts, things like part numbers and descriptions. And we have multi-CAD sources. We're not just designing in one application anymore. We're using a conglomeration of tools to make things happen nowadays. And another kind of disruptive technology was the whole digital prototyping revolution we saw a few years ago, where we started seeing more and more analysis come into the mainstream so that it can help validate design decisions along the way. So this is a lot of stuff that has come into just the design aspect of it, and helping companies take advantage of all of these different tools and methods, is part of that digital transformation journey. And you can see that there are different realms that we're talking about, right? Material libraries, just straight up CAD. We're talking about EBOM, interoperability, and computer-aided engineering, in terms of the analysis stuff. So it can be hard just gathering all that stuff and trying to make sure that we're extracting the most value out of our design assets. So here we've got a little video that we can play that kind of exemplifies what are some of the things that we can do in right now. So here we've got, we're filling out some metadata, specifically things about the asset that we're talking about here, not just part number or, things that are pretty generic. We're actually giving it specific metadata so that it becomes searchable. We're trying to classify how this equipment looks. We can edit the bill of material. We can even do things like specifying, spare parts and wear parts. All important, not necessarily for the CAD design, but for the downstream end consumer. And here, we're not only able to take this in the mechanical realm, but we can also formulate it and create what we call a BIM exchange model, and what we can do is we can put in building information in here. So like what type of connectors do we have? Do we have exhaust flow? All this, really important information. Again, not important in the design of this, but down the road, there's other technologies that can take advantage of some of the work that we put into it in this stage, so that when it is ready to go on to the next stage, they'll have that BIM tool, typically something like a Revit, will be ready to consume it, and it'll have some of that rich metadata already there. We're talking about how much voltage the motors will use, how much airflow the fan is pushing, and all that stuff can be embedded right into the models, and then incorporating a release process right in CAD. So again, what we're doing inside design tools nowadays is pretty hardcore. So what we got, oops. So next we have the connect phase. So again, we're kind of sticking with the same model. And here what we're going to see is what we're trying to do is connect. We're connecting it to other parts of the business. And here again, talking about that component metadata that we saw in the previous video, we're filling out things that are specific to this here. It's what kind of dust collector is it? What material is it processing? What kind of separation systems? And again, it's not important for the design itself, but for future use where somebody's looking to say, hey, did we have something like this? Let's go search for it. Here's all these little pieces of metadata that will help us find that information. Right, so then we have some sourcing and costing, right? Procurement stuff. So who's the vendor? What kind of lead time are we talking about? And what's the cost that's going to be associated to it? Next, we have company asset info. Like if you're tying a lot of this to your SAP system, right, we have to worry about things like asset tags. Where is it located? Is it part of a work breakdown structure? Again, all of that stuff can be incorporated into our models. Things like performance specs, where here we're talking about the fan. How much airflow does it work? How much airflow does it move? What's the brake horsepower, and what kind of temperatures do you expect with it, right? So all of this, again, is just that metadata that we can put into these models. And then one more, we also have the governance and control, what we saw in the last video, how we were able to submit the file to be released. So what state is it in? Who approved it? Some industries really need to understand. They have to have that kind of stuff documented. Revision, what current revision is it at? Right. So again, a lot of this type of information, not necessary for the model, but it's important for other consumers, right? PDM systems, ERP systems, estimating and procurement systems, integrations with supplier websites, and PLM systems, right? So we're taking this data and we're distributing it out to all these other systems that have different actors and different consumers of that data. And again, here's another video. And here we're showing one of the downstream systems in Revit. And what we want to do is show how we can bring in some of that mechanical equipment that we've designed and put it right into our architectural layouts here. And we're just going to go ahead, find that dust collector, and we're going to put it in there. And the great thing is that it's ready to be designed. Because we put that data in there about the connection point on that fan, Revit knows that is going to be a duct. And all we have to do is just start running those commands, and we can take advantage of that metadata and just start routing our duct and not have to worry about sizing it, placing it. All that stuff already comes in. So again, here we're just setting up the parameters for the height, the width, and all that kind of stuff for the duct. Again, we didn't have to know what size it was. We just knew because of that information we embedded in it, it comes across and we can start designing almost immediately. Next, we have the extend. So this is taking our data and extending it out beyond our organization, outside our walls. So again, we'll use the same model here as the basis of the discussion. Right, so we have internal collaborators. So we have engineering approval, design checks, change control boards, right? Those are some of our internal collaborators. We have engineering service providers that we work with, right? Different design houses, boutique engineers, and complete turnkey providers, right? So those are some of our other people that we work with, subcontractors, right? Who's building it? Who are the trades, and who's going to install it, right? So these are all the different stakeholders that have, you know, value in seeing this data. Our supply chains, right? Our vendors, our suppliers, trade partners, being able to get what we need out of our suppliers by sending them, you know, better requirements, better, you know, models that need to be integrated with. And then we have our downstream consumers, people like purchasing, project management, in the shop floor. Again, they're not in the, you know, engineering office, so they need access to this stuff because they need to buy it. They need to work with those subcontractors. People have to make it, right? So we need to extend this stuff outside of the engineering and outside of our building walls in some cases. Right, so we have different things like workflows, concurrent engineering with the partners. Very important, big topic nowadays is IP protection. You know, we spend all this time putting intelligence into our models, but we don't want to give away everything. We need ways to keep it safe, but we still need to have it built or constructed. So there are different workflows for protecting our intellectual property. Things like setting up cloud portals so that we have two-way communication between our partners rather than, you know, sending emails or what have you. And then inside the organization, then client access to, you know, where all this data is housed. So it's being able to have that self-serve kind of ideology rather than, you know, every time somebody needs a print, calling up the engineers. Let's put that in their hands, give them the opportunity to search for it, find it, and you know, kind of eliminate that little lag time. And again, here we have one more quick video. So again, talking about extending beyond the original scope of some of these models is, let's take this data and let's get it estimated right out of the gate, right? So we're taking our model, we're gonna push it up to a cloud application called Assemble, an Autodesk product recently acquired and, you know, being integrated into the family now. And basically all this is it's taking all of that data, all the metadata and models, putting it together in a digestible format that can eventually be estimated. We can integrate, you know, costing websites into it to get up-to-date pricing. We can get exact measurements, quantities based on all the different categorization. And once we kind of go through and select everything that, you know, in this case here, we want to see the mechanical equipment, some structural stuff. And what we're going to do is we're eventually going to get this, extract all of the metadata again, and formulate that into some kind of Excel sheet that we will see has costing information, quantity information, you know, that bill of quantities kind of idea. So here we have, you know, what can be done with that kind of technology, you know, that's extending what we've already done with our models. So next we'll get into a specific use case for digital transformation, what we're seeing lately is, you know, this convergence of manufacturing and construction. And you kind of saw that in those videos prior, where we're taking both sides and kind of putting them into one great big workflow. So what we're seeing with some customers, you know, even large multinational manufacturers, that they are in this digital transformation journey, and they've got all this stuff kind of dialed in, they're working on it. But then when it comes to getting that information out to the external partners, this is all they see. This is what their, you know, collaborators get, right? You know, great big firewall where all that data is locked within your organization. And one of these digital transformation journeys is trying to extend that out, make sure that everybody, all of our collaborators can take advantage of that technology. So in doing some research for this, I did find an oddly specific TikTok video that might help explain this in a little bit more of a, you know, humorous fashion.
Well, thanks everyone for coming to our kickoff. Awesome. Well, we came up with this concept using generative design, you know, AI and machine learning. Once we settled on the iteration that met the spec, we modeled everything in 3D and ran it through all the simulations. Oh yeah, we did them up in the cloud. And then it was all approved by our quality team and subject matter experts. And with all this technology, we wanted to help you out. Oh? Yep, that's a 2D PDF in an email.
So, you know, all joking aside, this is some of the things that we have seen with our customers, is that when it comes to collaboration, all of that data stays within the organization. And what they end up working with is just this minimalistic, here's what we've been doing for 10 years, 15 years, here's what our collaborators get, but we're going to keep all that cool technology to ourselves. And I think part of this, you know, coming together of the construction and manufacturing is we're going to start seeing that go down, right? And what we're seeing here again is the convergence of manufacturing and construction, where they do work together. You know, obviously a lot of manufacturers end up supplying to architectural and general contractors for buildings, plants, and factories. So there does have to be a level of coordination between them. And what we're seeing is you know, what is driving this convergence, and what I'm seeing here is it's the removal of barriers, right? So, you know, first of all, we're getting that enhanced collaboration. We're able to get this information designed in-house, but then we're able to extend all of these extra things into the cloud so that it's more accessible to all of our stakeholders. And it comes with the 3D, it comes with models, it comes with metadata, right? It's not just this 2D print. It's you know, we're getting that enabling or enhanced collaboration. Another thing is enabling workflows, right? Trying to get all these disparate systems working together in a nice fashion. You know, again, kind of like what we saw with the n squared problem earlier, you know, as you have more and more technologies, you have more and more interfaces, and trying to navigate how all of those fit together, you know, in some of the before times, it was a real problem. You know, we couldn't get one to talk to another very well. And what we're seeing is that those barriers for workflows between those technologies are coming down. And most specifically is, you know, one of the things that is real big for us this year in 2022, the product release 2022, is that basically there is a seamless integration between Inventor and Revit. I think this is going to be one of the biggest driving factors that help us along this convergence path, is that when we're working with architects, as machine and equipment designers, we can integrate our designs much more seamlessly than ever before, right? And that's one of the biggest things that we've heard from customers is like, hey, we've got these technologies from Autodesk, let's get them to talk together. And now they're doing that. And again, it's removing those barriers for design. And so again, that was basically our little approach and overview to the digital transformation. I appreciate your time here. And now we're going to go ahead and open it up to questions.